Welcome. Take a deep breath, settle in, and let's clear away any residual exam anxiety you might be holding on to. Today, we are opening our digital notebook for a highly focused strategy session. We're looking specifically at a crucial module, Cambridge AS and A-Level 01 Mathematics 9709. Specifically, we are diving deep into the Cambridge AS and A-Level 024 integration focus, and even more specifically, the constant of integration. Now, I know calculus can sometimes feel like a whirlwind of abstract symbols, but today, there's no rushed panic. There's no crammed memorization. We are simply going to decode one of the most subtly complex, yet highly rewarding areas of the syllabus. I want you to visualize your upcoming exam paper not as a threat, but as a pristine, blank canvas. Together, we're going to build the architecture of a perfect, undeniable response, line by elegant line. By the time we're done here, when you sit down for paper 2, you're going to operate with total, unshakable confidence and absolute authority. You're in safe hands. Let's begin. Okay, let's dive right into this, because this single number on your screen is the absolute foundation of our entire session today. 15%. That is the approximate massive weight that integration, and specifically the nuanced, careful application of the constant of integration, carries in the total marks for paper 2. I really want you to just sit with that for a moment. 15% isn't just a tiny fraction of your grade, it is literally the entire boundary between a B and an A, or an A and an A star. It is a massive, high-yield target sitting right there on the paper. And yet, thousands upon thousands of highly capable candidates leave these exact marks on the table every single year. And you know what the tragedy is? It's not because they don't understand calculus. They know how to integrate, but their structural discipline breaks down under the pressure of the clock. They drop a symbol, they miss a step, and the marks vanish. Well, not us. Not today. Today, we are going to reclaim that 15%. We are going to lock it in with absolute, undeniable certainty. To achieve that level of mastery, we're going to follow a very clear, calm roadmap. First, we'll cover the zen of decoding command words. Second, we'll observe a serene, collaborative study debate. Third, we'll take an intentional focus reboot. Fourth, we'll step into the visual satisfaction practice arena. And finally, we'll wrap up with a systematic recipe recap. Let's transition into Act 1, the zen of decoding command words. Let's peel back the layers of exactly what examiners are looking for. Now, before you even think about integrating a single variable, you really have to understand the psychology of the examiner. The Cambridge examiners aren't just scanning your paper for a final magical number. They actually want to see a specific, transparent demonstration of your interconnected understanding. I want to share a direct quote right from the Cambridge Principal Examiner reports. It says, "Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you." I want you to deeply internalize this concept of the method mark. It's your ultimate safety net. Let's say you're deep in a calculus problem. You might make a tiny arithmetic error, maybe you drop a negative sign, and that throws off your final curve equation. But if your procedural working is pristine, if your mathematical syntax flows logically from step A to step B, the examiner can and absolutely will award you method marks. A wrong final answer does not mean a failed paper. Your working is the proof of your logic, and logic is what they are grading. So to protect that safety net, we have to meticulously avoid what the principal examiner reports identify as the top 3 unforced errors. I like to call these the focus drops. First up on their warning list, vague details lacking specific integration steps. Look, if you skip straight from the integral notation to the evaluated expression without showing the intermediate algebraic steps, you are completely blinding the examiner to your logic. They can't reward what they can't see. Second, poor format and rushed presentation. Mathematics is a language, and it follows strict, elegant conventions. Proper headings, aligned equal signs, and correct terminology are not optional stylistic choices. They are the fundamental grammar of the discipline. And third, answers disconnected from the mathematical context. Imagine a question gives you a specific coordinate that a curve passes through. If you just integrate and leave the plus c floating there, failing to actually use that coordinate to solve for your constant of integration, your answer is literally floating in a void. It's meaningless. We are going to counter these 3 focus drops with what I call the marks per minute flow formula. This ensures that every single minute you spend writing directly correlates to a guaranteed mark on the grading rubric. Moving smoothly into Act 2, the serene collaborative study debate. Let's step into a shared digital workspace and see how top scholars actually build their answers. I want you to imagine 2 dedicated scholars, let's call them Alex and Sam, and they are collaboratively tackling a really dense, high-tariff past paper question right now. You can picture their shared screen. Now, Alex is highly analytical. Alex's immediate instinct is to write out dense, text-heavy textbook definitions. He starts furiously typing out sentences about how integration is the exact reverse process of differentiation, mapping out all the underlying theory. He's crowding the page with facts. But then Sam, who is a bit more dynamic and creative, steps in and points out a massive structural flaw in this approach. Sam says, "Alex, look at the command word. You aren't connecting the math to the specific parameters of the prompt." You see, the question is explicitly asking for the specific equation of a curve passing through a given coordinate. Sam rightly argues that if you spend 3 precious exam minutes writing out an essay on calculus theory, you are burning time, you are breaking your flow state, and you aren't earning a single mark. The examiner doesn't want an essay, the mathematical working itself, the act of cleanly integrating the function, explicitly stating the plus c, and then immediately substituting your given x and y coordinates, that action is the proof of your understanding. The theoretical architecture is proven by your precise execution, not by reciting facts. It's a really fascinating debate, but Sam hits the nail on the head here. So how do we bridge that gap? This clean table right here perfectly illustrates how to align their debate with what the examiner actually expects. This is the transition from a good student to an A-star candidate. Let's look at the analytical element framework together. When we talk about evidence quality in mathematics, a flawed execution simply ignores the underlying assumptions or boundary limits of the function. But the examiner expectation? They want you to actively identify those limitations. Down on the third row, look at result justification. This is exactly where Alex and Sam were getting stuck. A flawed execution rushes to a final number, or worse, stops halfway. For example, leaving your final answer as y equals x squared plus c without actually taking the time to solve for c. You've done the hard calculus, but you failed to justify the specific result. The examiner expects you to draw evidence-based conclusions using the provided coordinate data to lock in that specific, unique final equation. Strict, unwavering context adherence is the ultimate key to Cambridge mastery. Let's glide into Act 3, the intentional focus reboot. This is a deliberate cognitive pause. Let's just pause the on-screen handwriting for a second. Breathe, relax your shoulders, refocus. Before we write out our final top-band mathematical structure, we need to make sure your daily study dashboard is actually complete. If you haven't already, subscribe to Ace the Exams at the handle @AceTheExams right now, and make sure you enable all notification alerts. Whether your specific target is an IGCSE, an O-level, or securing that AS and A-level A-star, this channel is your dedicated weekly space for stress-free exam mastery. Securing your resources like this is step 1 in minimizing your cognitive load. Okay, let's get back to the math. So Alex and Sam have hit a structural roadblock mid-calculation, and their equation blocks are losing alignment. How do we calmly restore balance? We rely on a brilliant memory hack straight from the examiner insights, the DES-EP procedural framework. Let's walk through this 5-step procedure together. Step 1 is deconstruct. You deconstruct the question constraints. Calmly read the prompt and identify your boundary conditions and the exact required format of the answer. Step 2 is extract. You extract the relevant calculus data. Pull the derivative and those specific coordinates right out of that dense block of text and write them clearly on your page. Step 3 is select. Select your analytical framework. You need to instantly know whether you're dealing with a standard polynomial, a trigonometric function, or an exponential, because that dictates your integration rules. Step 4 is execute. Execute with clear, calm notation. Show the integration line by beautifully spaced line, and absolutely crucially, append that constant of integration, plus c. Do not forget it. And finally, step 5 is present. Present with exact terminology. State the final equation clearly, fully substituting the value of c that you just solved for. If you apply this DES-EP framework, you create a completely impenetrable defense against lost marks. Welcome to Act 4, the Visual Satisfaction Practice Arena. We're going to do a mindful scan exercise right now. I want you to look closely at this complex, flawed student calculation we've pulled from a past paper. The student was given the derivative of a curve and a boundary condition. Now, at first glance, the handwriting is beautiful, the layout looks neat, but mathematically, it's a complete tragedy. I want you to calmly scan this and tell me, where exactly does the structural discipline break down? Where does the method mark vanish? Look closely at the integration step. Do you see it? Right there. By simply evaluating the integral and writing y equals x cubed instead of y equals x cubed plus c, the student has entirely erased the constant of integration from existence. And because of this single split-second omission, applying the boundary conditions later on becomes mathematically impossible and logically nonsensical. The entire cascade of method marks is completely lost. A simple mindful plus c right at that crucial step would have saved the entire paper. It's a small detail, but it carries immense weight. To ensure that kind of error literally never occurs in your exam, we are going to apply this beautifully spaced 10-minute chronological processing timeline. This is your systematic path to examiner compliance. When you hit a high-tariff integration question, here is how your time flows. Minute 1, identify key elements. Don't rush to calculate. Extract the derivative and the boundary points. Minute 2, apply integration principles. As you perform the reverse differentiation on the page, that plus C should flow automatically and naturally from your pen. By minute 6, execute analysis with clear working. This is where you substitute your x and y values to isolate and systematically solve for C. Minute 8, verify results and assumptions. Take a breath. Look at your calculated constant. Does it actually make sense within the geometric context of the curve? And finally, minute 10, present final format. Rewrite the entire equation from scratch, replacing C with your beautifully calculated, verified number. This timeline guarantees maximum mark retention, and it entirely eliminates rushed panic. And finally, Act 5, the systematic recipe recap. Let's look at the finished product. As our focus meter visually maxes out at 100%, let's distill this entire masterclass down into 3 serene, unforgettable pillars. These are the core tenets of our strategy. First, the 3-step question scan for decoding. Never, ever start calculating without isolating the exact assessment objectives. You must know precisely what the command words are demanding of you. Second, the marks per minute flow formula for timing. Ensure that every single line of algebraic working serves a distinct purpose. Keep the method mark strategy in mind. Showing your detailed line-by-line integration steps protects your grade completely, even if a minor arithmetic slip happens later on. And third, the final polish review pass for verification. This is that crucial final moment where you double-check that your constant of integration has been explicitly stated, correctly solved for, and perfectly presented in the final equation format. If you internalize these 3 pillars, you transform complex integration from a source of deep anxiety into a highly satisfying, totally manageable logical puzzle. So, as we wrap up this explainer, realize that your exam paper is no longer a threat. It is simply a canvas for your clear, focused logic. If you found this strategy session valuable, please remember to subscribe to @ACEDExams and click that notification bell so you never miss our future focus deployments. I want to leave you with one final provocative question to think about. What specific subject, tier, and target grade are you currently meditating on? Leave a comment below. Declare your target to the community, maintain your structural discipline, and I will see you in the next strategy session. Stay calm and stay focused.